Okay friends, I will create a new project and create an object for better explanations. I will turn on the display of the grid for better orientation in space. Also, we'll set a bit smaller radius for our sphere and increase the number of segments. Okay, first of all, we should create a TurbulenceFD container inside of which our file will be generated later. We should place our sphere inside this container and have some additional free space around it. I will increase the size of this container, but not too much, and adjust its position. So now we see our sphere is fully inside, but nothing is happening yet, because we should add an emitter and be sure that the emitter active checkbox is ticked. Also, we need to open the simulation window. And here, in a cache, you should decide where to save your cache because it takes a lot of space. You can name your cache folder as you want. For this tutorial, I will create a new cache folder, explanation as its explanation, and press start. But nothing is happening yet, because we need to add some values in temperature, because now with 0 values our container doesn't understand where to get information needed for the fire. If you put 1 and press start again, you will see that fire is generated now. We see our fire in 3D. It's pretty primitive now, super simple. But we see that we created a fireball in a minute, and all the other time we will be adjusting TurbulenceFD settings to achieve the best result. If you don't see any result, be sure that in your render settings you have the TurbulenceFD renderer option enabled. Let's go to the emitter, and now we're gonna learn and check the settings one by one. I will explain to you what each setting is responsible for. And the first one is radius. This about how dense and close to each other the fire and our object will be. The closer to the object, the tighter and stiffer it is. Let me show you some examples so you see the difference here. If we set the radius too small, it will uncover some parts of your object. If the radius is large, it will look like an aura or a mini force field around the object. I will set the radius to 1, and maybe we will change it a bit later. If you see some uncovered areas, you should tick Fill Object, and your model will be fully covered with simulations. So I usually use this checkbox to overlap and cover some gaps on my object. What else? Restrict to Polygon Selection. It's about the restriction of our fire to some specific polygons on our object. I will select some random polygons for better explanation. Yeah, we do our selection. Not perfect, but for example, it's good. We see that we selected and textured a specific zone. So if we want the fire to be produced and generated only from these selected polygons, we need to send the Polygon Selection tag to the restriction window in emitter settings. Untick Fill Object, as we don't want the full object to be in a fire now. And don't forget to enable TurbulenceFD container to see our result. After setting everything up, just hit the Start button to calculate a cache and simulate fire. We see that fire is generated only on our selection, so very useful in some cases. You can experiment with it, and if we render this image, we see that it really works. Yeah, we still have a lot of settings here to be done, but yet, at least we know how it works. So I will just return everything back and recalculate the image so we see a full sphere covered in fire. So let's see other parameters. Collision object. We will learn it a bit later. What else do we see? Texture tab. Yeah, texture tab. Oh yeah, I forgot to return fill object. If you do any changes, you should resimulate everything again. So now our fire is generated from each polygon. 100% of our surface is generating fire. If we will create a noise map, fire will be simulated only on a white part of the noise shader, and on black it will not be visible. So let's see here different examples again. 3 examples with different noise maps, but every other settings is the same. With different maps for fire, we are able to create different fire tortuosity, hence different fire flames. Now it flies out of the core in different ways, so this difference was achieved only with the help of noise maps, which are inside the texture tab. Yeah, and don't worry about the primitive look of our fire, because it's just the beginning. I will set in this parameter my most common settings, noise texture, blistery turbulence, and global scale to 500. It will include some specific zones without fire generating and bring a bit of randomness to our work. Maybe we will change it later, we'll see. Let's go to other parameters in our emitter. These 2 tabs, particle emission intensity and force, we will skip for now, therefore a bit more advanced setups. And here is the temperature. 3 examples of different temperature values. The difference and importance can be seen with the naked eye. The settings here 0.2, 1 and 100. We see that the higher the temperature, the more epic and nuclear it looks. Also, some more detailed spurts of flame can appear and it becomes a bit less saturated. It's a very important setting, and after this tutorial you could also experiment with its values. But the success of a good fire is its combination of different settings and the temperature. We will return to this tab after some more adjusting, but the main thing that changes our fire is inside our container. Let's select it and see what we have there. First of all, it's basic and coordinates tab. It's always pretty much the same. Container tab is more important here, and let's start with the first parameter in resolution category, which is called Voxel Size. Our beautiful comparison with 3 examples is already here, and take a look at these examples. Everything is the same except for the size of voxels. We have 5 cm, 1 cm, and 0.2 cm. The smaller size we have, the better resolution and quality we'll get, and more diverse it becomes. We will have more voxels in our image, but it pretty slows down our render, because it has much more information to calculate and simulate. But it's worth it. Just take a look at this difference. It's super different. You can enable here Show Grid to see the size of each voxel, so just compare it. Obviously, where we have a size of 5, the particles turn out to be super huge and hardly intertwine inside at all. A small value is perfect here, but your computer may be offended if you set super small values as 0.01, for example, I usually use something like 0.4. It's good for the project and my computer. Sometimes you can work with lower resolution and then change it closer to render. Okay, let's go to the Simulation tab. There are also some quite useful features. The first important setting here is timing, and it helps you slow things up in bullet time or fasten the entire animation. Here are 3 examples with different time scales, and in a right container I also have some keyframes from 500 to 25. You can see that the bigger value we have, the faster it burns. Use these parameters to achieve the most needed result and diversify your project. Wind. Wind is some power that affects our fire direction and its flow. If you need to create a scene with fire and wind, like it's in stormy weather, then use this wind to affect the fire. I set up here different wind speed values and different directions, so you can compare how it forces our particles to go in some specific directions. So if you need it, use it. In our Ghost Rider scene, we will not use it as we don't have any environmental stuff and powers, but in general, it's a really cool setting. Oh, by the way, if you're wondering how I did this orange display of fire, go to the Viewport Preview tab in Shader and choose Fire Shader. Okay, moving on. With timing and wind, it's easy to understand how it works and use it. What we still need to know is how to use this one, turbulence. Super significant. On the screen you can see 3 different combinations of values. When turbulence is pretty big, we see that the fire produces additional forks of flames, which also adds diversity. It becomes more detailed. Remember how many settings we've already discovered and learned about: wind, time, turbulence, texture, voxel size, and so on. A good combination of these values will make an awesome result. Here I will set the intensity to 10 and the size from 0.5 to 2.5. It shows a size range of our voxels that will be distorted. Maybe we will change it after applying this to our character, but right now for the sphere I will use it. Temperature is also a very good parameter, where we are interested only in cooling and buoyancy. Let me show you how they work. You see settings. The right side example has 10% cooling, we have 7% in the middle, and the left one has only 2% of the effect. It's just literally cooling. The bigger number you have, the faster our fire will fade. It stops the fire from being high. Now, take a look at another example with the same cooling values as before, but with lower buoyancy power. If we set up the same cooling settings, but different buoyancy, we will also get a diverse result. It adds to our fire density and viscosity. Buoyancy helps the computer understand how fire should behave when it's in air. It also adds to our fire density and viscosity. The software uses buoyancy to help the fire look like it's floating and moving around in air, just like real fire. My settings are 2 and 5, not too big values, so our fire has more freedom. And let's simulate it. Okay, I will go to the Rendering tab in Fire Shader, Mapping, and show you fire color mapping. This curvature shows the color of our fire over time. Now we have a big level of yellow. I want yellow to disappear faster and the fire in general to be not so cut and stylized. Use these rounded icons to make the color transition smoother. Right now, I adjusted in such a way that the peak of our color brightness lasts less. You also can change the whole look. You can create here green, pink, rainbow colored fire. It's again up to you. For more understanding, I will show you again 3 different examples with diverse graphics. Right away you can notice a difference in color. Extra vivid, normal, and super soft and transparent fire. And all of this is achieved only with the help of curves. Experiment with different drawings and see where it takes your simulation. You can again edit the color if you want. I will leave it without changes. You can also switch the shader here to see the draft of how the fire will look, or take a look at a smoke shader. For now, I will use this shader. Let's recalculate everything again with our graphic mapping settings, and let's see what it looks like now. Yeah, now it's much better. We can see some transparency above the sphere, and it's good. Inspect your fire, it looks pretty cool. If you need any close-ups, like fire detail, you can find a perfect angle, set a camera and use timing to create an epic macro slow motion animation. But still, we have some settings to be set. Of course, you can just copy all the values you see in a tutorial, but I highly recommend you to experiment and play around with these parameters. It would definitely increase your VX skills and you will memorize everything much better. Generally, we covered all the main features for now and we are ready to move everything into our main comp. So, group it and let's name it Fire. Cut with Ctrl X and paste it with Ctrl V in our main composition. Yeah, now we don't see our fire. Be sure that in render settings you have TurbulenceFD. And still we don't have any fire. By the way, you are able to place TurbulenceFD buttons wherever you like. I usually have them right above the preview panel and main icons. Oh yeah, it's because of the camera. It's strange, but when we have a parallel camera, we don't see fire. This is just a fun thing to know. If you have parallel camera, then disable it to see the fire. You will be able to turn it on before rendering and export it with any camera you want, but for editing and adjusting while working inside of Cinema 4D, it's better to disable it. So just for the working process, disable this projection and after setting up everything, we'll turn it back. We have this mushroom of particles. Let's switch the visibility of all layers we don't need, so we see only the fire. And now we must save the project not to lose our progress. Yeah, the project is saved. And now one of the most interesting part. We're going to transfer the fire from the sphere to our character. But we need to set only the skull on fire, but we have all the Ghost Riders as one object. To have perfect collision and more flexibility, I prefer to divide our object into skull and body. If you need a fire for all men, you should just copy and paste fire to the subject, but I will tear the skull off from the body. So I will duplicate the object by dragging it with Ctrl held down, disable one of them, go to the upper layer, turn on Polygon Selection. Also, let's rename it into Skull and the other object into Body to not get confused. In one object, we will delete the body, and in another one, vice versa, we will delete the head. Just select and delete the polygons. Pick the Live Selection tool and set the size that's comfortable for you. Uncheck Visible Only, and here goes. Nice and easy. Select and delete it. Okay, we left only the skull here. It will move the same as our body as it still has rig animation, so don't worry about it. Now let's do the same with another object. We just destruct the skull from the body and the body from the skull, and make our already animated object more like two different subjects. Done. You can do whatever you want. You can disattach arms, legs, and so on from the body and set on fire everything you want. Skull is animated, perfect, and the body will serve for us as a collider body. Fire will be colliding with this body object. Now we can return the visibility of all layers. Everything works perfectly now. Turn on fire. Now we are proceeding to adjust the TurbulenceFD container size. Our Ghost Rider should be fully covered by the container because fire is generated itself only inside the container. And if Ghost Rider will move further out of container boundaries, it will cut fire, like jumping out from a room where he has magic abilities. You probably noticed that the fire has disappeared after 110 frames. It's because in the previous project we calculated only this range, but we will make it last longer. Finally, let's apply our fire to the character. Select Emitter and arrange it to the skull, but disable the sphere visibility. If we calculate it now, this will already work. Emitter active checkbox is ticked, and the radius is 1, temperature is 1, everything is okay. Now go to Extensions, open Simulation window, press Start, allow Cinema4D to override our first animation and observe its calculations. After 16 minutes, I stopped this animation because it's enough to understand how it works. And I have something to show you. First of all, we see that the fire we were testing on a sphere, it's attached to the new object. But I noticed two things that I want to adjust. The first one, the fire trail is too long and leaves too much. We need increased cooling here, and we should add more dispersion. And a second thing, it doesn't collide with the body. Our fire passes through the body without any resistance or reaction to this. We should fix it, but don't worry, it's super easy. And by the way, for some of you, this result may be more interesting if you work on fireballs where you need an object fully covered with fire and had a long trail. I mean, maybe it will work for someone's idea. In the middle of the animation, we can make sure that the fire is done pretty roughly. Let's return to our Simulation tab and find Turbulence and Temperature. What I want to use is Cooling, Buoyancy, and Turbulence Intensity. For all of them, I will set keyframes and animate them. A bit more turbulence, 10. Cooling needs to be doubled, at least 5, and a bit less buoyancy, 2.7. And press on the diamonds to fix your values at this time. After Ghost Rider achieved its final position, about frame 90 in my case, turbulence intensity will be increased to 14, cooling to 15, and a bit less resistance. I will use 1.5 for it. I mean buoyancy. So that from 60 to 90 frame, cooling goes up and fire trail disappears faster. Now, duplicate the emitter to the body by dragging it to your object with Ctrl held down, untick Fill Object, and activate Collision Object, and just in case, let's turn off the temperature, as we use the body only for colliding, but not for simulating. Radius will be also disabled, so basically, all you need here is an activated collision object. Everything else is not so important. I guess we did all the edits I wanted to do. Let's simulate it. Let's also change the shader for the preview to better estimate our result. The simulation has finished. Now we see that fire is indeed colliding with our object. It's more chaotic, less long and less regular. Looks more magical and epic at the same time. But I see that even now, after so many adjustments, we still have room for improvement. I don't like the fire behavior at the moment when our hero is landing and touching the ground. I want a fire to be wilder, more splashing at the moment, so we have more volatile particles. So let me just remember how we can do this. In general, everything is okay, but I just have this feeling that this fire is lack details. It's too smooth. Let's pre-render again. Oh yeah, I forgot to enable cache velocity. Cache velocity can improve the quality of fire simulation by allowing the simulation to store information about fluid velocity, making it possible to use this information across multiple frames and improving simulation stability. This results in a more accurate and realistic representation of fire behavior. Also, caching velocity information can also improve simulation performance by reducing the computational cost of calculating velocity at each frame. Okay, all we need is located in a container. By the way, I decided to put here a bit less than 4. It's 3.7. I recommend you set voxel size as small as it's possible for your computer to have better quality result. And the main thing which we forgot to do is to enable cache velocity. I will create a new folder location and it will be called Final because we are really close to finishing working on it. Cache velocity will increase render time, but will add a beautifulness. Also pay attention to subgrid detail in the rendering tab. I have velocity displacement 3, but let me once again show you and explain what it means. I have here 0, 3 and 10. Velocity displacement is a way to make fluid simulations like fire look more realistic by using information about the speed of the fluid from our just enabled cache velocity. To add small details, Using both of these techniques helps create a more believable and interesting simulation of fluid behavior. Right now, we don't see a difference in the viewport. It's always like that, but if you press render, you will see the difference. Now you understand why we have done it the right side fire with additional details, shutters into particles, and I enjoy it. Maybe it will fit your idea, but I go into use the middle one settings. So again, I recommend you to turn on cache velocity and set velocity displacement to 3. Okay, now we improved our fire, so let me close it. Here everything is good. I will save this project incrementally again, always do this. And you know what, I will set to 0 our radius, so it will be closer to our skull, and I will delete the texture. I had to show you how it works, but I just want my fire to be generated from each polygon, so we have more burn voxels. And now, finally, we should have our fire perfectly set up. It's time to press start and recalculate everything again with our final improvements. Oh yeah, perfect. I've already noticed that the fire is exactly as I want it. Skull is neatly covered in the fire aura, and I believe now we can start exporting this for future compositing. So we officially finished creating and learning fire features in Cinema 4D. Congratulations! All the other things like color correction I prefer to do on compositing, so if you are at least junior, I guess you probably know how to export everything. And this is the moment where you can probably stop watching this video and continue adjusting and compositing it by yourself. But for those of us who have no idea how to export, I will show you just the usual methods with usual formats, not as OpenEXR with much information in it, just the simplest export for standard layering in After Effects. Go to your render settings. In Output, just make sure that the frame rate and resolution are okay for you. In Save tab, I prefer use PNG sequence and render alpha if you need. I won't export it with alpha as I will use blended modes and I don't need transparent background. So as an option, I will put black material on our hero. Create texture and just antique color and reflectance. Sometimes you can find this method useful, or you can just disable them from render. And always double check all settings. Also, let's turn on camera. And I will put it up a bit. Just take away this protection tag, edit the camera, and bring the protection tag back. And press render. Okay, it's already beautiful. This silhouette scene with some color correction can work even without our hero. It's already awesome. Let's keep going. Let's render out body without the skull. We should return the original material to the object and let's disable emitter active to remove fire from our body. Oh yeah, fire is not disabled because we need to untick TurbulenceFD renderer in render settings. So now everything is good. But we shouldn't forget about our light setup. I turn on the light scene we had created before. Now we're ready to export it. Export this with alpha channel and render it. And now we render our last object, but not at least. Also with alpha channel. Don't forget to re-render it. And now a bonus. There is no smoke without fire and no fire without smoke. So I want to show you how to create smoke from our fire in less than a minute. Return black texture to our hero and enable TurbulenceFD renderer again. Let's go to TurbulenceFD container, rendering, and find smoke shader. All you need is to set the temperature in mappings channel, so our smoke is generated by our temperature, and a fire channel is vice versa, set to none. So in end, we have only smoke. You can edit the color, but anyway, I will make it black and white in After Effects, so I just press render. Okay, so we did smoke in a few clicks. Once we finished working in Cinema 4D, I will save the project and go to After Effects to assemble everything. Import all your 4 sequences in After Effects: body, skull, fire, and smoke. Create a new composition. We see that it has transparent background. Let's call it main. And our layer body. Put here the skull, rename it to skull. Everything is okay with transparency. But as we separated them for better color correcting abilities, at some moments it's on top of our body, as when we see our back it's covering our shoulders and so on, so we should fix it. Let me show you. We'll just change the label. So the idea is to just cut the skull as many times as we should, putting it back or behind the body, depending on the situation. Use Ctrl-Shift-D to cut and drag the layer. It's done. Double check everything. We have a transparent background, and now we have time to color correct our skull. As we cut this layer into many pieces, the best way to apply color changes to all our skull layers is to create skull composition. Rename it to skull color correction. And what I also like about labels is that you can easily select all our red labels with 2 clicks. And after all your files are selected, hold down Alt and drag and drop on them our skull composition. It will automatically change the source of these layers from sequence to our new composition. This tip is super often used by motion designers all the time who worked in After Effects, so use it when you need to replace something. Let's also add our fire and smoke. They are integrated without transparency, so to overlay them on top of our hero, I will use screen mode. As usual, I'm setting an orange label for simulations and green for the body. And as we are professionals, let's clean up a bit in a project window. Just put our sequences into a folder and rename it to renders. Always keep clean in your projects. Save your project so you don't lose anything. Okay, we see the clean fire. You know, I like how it looks without any objects, but of course we need to see them. So set the layer to screen, and now it's placed on top of our smoke. Screen mode again, and finally we see all our layers. Remember that we don't have transparency in our simulations, so from now we can't export this composition with an alpha channel. But if you need it, just render fire and smoke with enabled alpha channel. Perfect. Okay, we're almost ready. You can keep working on it, adding your own effects, but I just want to make a few color adjustments. Smoke shouldn't be pink, that is why I'm gonna add black and white. And set the opacity to 35 to make it more smoky. So now we have more emphasis on fire. I still need to make our skull a bit darker, but try to just cover your needs with all instruments you need. You can also animate color correction and set some keyframes when it's without fire and then with it. But I will not do this. Using these curves, I just did it a bit darker and contrast. And the last thing I wanted to show you are two plugins that I use sometimes for rendering the result. You can notice some sharp zones in our layers. And to fix it, if we have some files without motion blur, I sometimes use Real Smart Motion Blur. If we apply it, we will see that all moving pixels are blurred, and the more pixels move, the more they become blurry. This plugin simulates a more realistic and natural-looking blur by taking into account the movement and velocity of each pixel, giving animation smoother and more fluid appearance. And I will add one more adjustment layer to show you the final plugin with a library of color presets. You probably know that one is Lux from Red Giant. I use it sometimes, but I can't say that it's often used in professional work, but for some works it may be useful. Let's pick up something from the blockbuster Cool, and now it's super saturated, but why not? Again, don't follow all the steps literally, I just want you to get the idea of how it can be done, and of course you can export file with Redshift and use DaVinci Resolve and Nuke for compositing, track it to your footage, and so many things on. That's it, folks. Now have the knowledge to harness the power of TurbulenceFD and bring your fire vision to life. Remember, the sky's the limit, so never give up on your creative endeavors. Give this video a like and hit that subscribe button for more tutorials like this. Have a great day.